I think I looked up a YouTube video on.
All right, it is 12, it's time to get started.
Just like,
Does anybody have any questions or discussion points or topics before we dive into the rest of our testing slides? The end of this slide deck is the end of what will be on the exam on Friday. So any questions about exam, studying for the exam, I tried to put as much into the study guide as I could with regards to how I would study for my own exam. What options and opportunities does everybody have? So everybody knows about the CS Discord and how to get involved with the CS Discord. I just think everybody should be in that server, just so you can see what's posted to the 212 channel. You can mute everything else otherwise, but that is a good place for if for some reason I'm busy and you need an answer to a question very quickly, you can post it there and the entire department has access to that. So you can get a response from somebody. It may be somebody who's taken 212, it may be another professor, it may be me if I see it before I can get to reading my email. Who knows? But it gives the class, the more people who are there, the faster people can get responses to their questions. And especially when it might take me up to a few hours or a day to get back to you, that can certainly be a way to get answers to questions faster. Anything else?
do you have a link to that this one?
It's in the study guide.
Oh, okay.
An invite link is in the study
I
guide.
definitely looked already, yep.
Were there any questions from people from going over the study guide? I tried to keep it fairly vague, but also specific enough where you might be able to come up with the kinds of questions that I might ask you from that topic list. You can imagine what it's like from my perspective. I've not written the exam yet, but what I do is I just look at that study guide and I will pick some things that I find to be either important or easy to generate a good question that tests your understanding of something that is a learning outcome from the course. And every topic there has some question that I could write about it, at least one, possibly infinite. But I will just go through that list and come up with as diverse an exam as I can that tests as much of it as I can with as few questions as I can. And make it doable within 50 minutes. That's always the hard part. All right, I will continue asking the question at the start of class throughout the week, just in case questions come up. Normally I would have, if there was more content on the study guide, I would have an actual class dedicated to review where people could come with questions, but I just don't think we've quite covered enough to fill an entire class period. So I'll just take the start of each class and ask if anyone has questions, and then maybe the first 10 to 15 minutes of any particular class can be questions on anything from the study guide. And that's perfectly okay. So make sure as you're studying, come up with questions for me. I am available in office hours, but I also like that to disseminate the answers to the rest of the class. And the easiest way to do that is if you ask the question in class. Then everyone can see the answer. Okay, so last time we talked about coming back to this exercise where we're looking at a date object and trying to figure out, is there any way it can get into an invalid state? What tests do we need to write to figure out what is an invalid state? And then honing in on the add days method, wherever that is right there. How do we ensure that that works properly with some subset of tests? So what did people come up with? Let's start with getting into an invalid state. What is an invalid state? I think we talked about this before, but let's refresh ourselves here about what is an invalid state?
Like 0.
Yeah, so a date object is made up of days and months and years. So is there any potential value of those days and months and years that would produce a date that doesn't make sense?
Negative numbers.
Negative numbers for any of those? Absolutely.
32 and up for days.
For days, it would depend on the month though, because like for instance, February never has a 31st or a 30th. So we need some kind of enum or some structure probably, and again, we don't need to implement this, but we would assume because we have the get days method right there, get day, gets the days, there should be a days and month, yeah, days and month right there. that will return us the number of days in the month. So we can utilize that method to figure out whether or not something is invalid. What do the actual tests look like for that? What tests should we design? How many of them? What should they be testing?
Bare minimally, at least one test per the structure of year, month, whatever.
Yeah, we want to test them all separately, right? And that way we don't have multiple assertion statements. This is one of the things we talked about in good tests versus bad tests. We don't want there to be multiple assertion statements in the same test, because the first one that fails, the rest of them don't get tested. So if we tried to test all three of them for negative and all three of them happened to be negative, then we're gonna see whichever one we test first fail, and we know nothing about the passing or failure of the other couple tests. So we're gonna make different tests for each of these. So we need a test for the number of days. We can test the lower threshold because there is no 0th day of a month. So check it, see if the value is 0 or less, or if the value is greater than whatever days in month returns. If either of those happen, you can just do that with an or, then you'll throw some kind of assertion and that will fail. So that would be test number 1 for get day. For month, we need to figure out if it's 0 or below, because there's no 0th month or a negative month, and there's no month above 12. So we'll just write some test that sees, is that out of the associated bounds? For the year, now it becomes interesting. Do we want to be able to represent years before year 0? Maybe that's a negative year. So maybe we do want to test for that. Maybe we don't really need to test any particular year because every year is going to be valid. Is there any way that the year could become in an invalid state that anyone can think of?
There's no year 0.
Okay, yeah, we went from like -1 to 1. So throw an error if it's 0.
If it leaves like an amount we don't want, like say it goes from 2024 to 2026 or 2030 something.
That would still be, so we want to make sure that, yeah, we're able to get things working properly, but that would still be a valid state. The transition would be where the issue is. If you think about we've seen graphs before in data structures, for those who have taken data structures. You can just kind of model this like a from to a to. Let's like label this from to, and then we have some operation that gets us, we call some function. And the question is, the only thing that asking about this being an invalid state is what is the state of the object here? What is the state of the object here? Are those legal, yes or no? And so we're going to separate the states from the transitions and errors that can be found within a state or errors that can be found by transitioning from state to state. So something like adding a single day and having multiple years elapse is an issue with the transition, not the value of the from or the to state. I'd be punishing people for having a time machine. And an invalid state would be getting in your time machine and entering a date that cannot exist. All right, so I think that helps us with the tests needed for an invalid state. Let's talk about whether or not add days works properly. What subset of tests would we need to write for add days? This is now a transitionatory function where we're taking a from date and a to date, and add days is the transition. So now we're going to test this transition to make sure, basically this is going to be phrased like given a from state and some transition via add days. basically, is this correct?
So you would want to test to make sure that month rollover works as
Yep,
well as year rollover.
so let's write the names of these tests, because we talked about how test names are really important. So we'll call it one, because maybe we want more than one of these. What states where would month rollover be really important to test? We can test something like a June 30th plus 1 day and make sure that that happens. What test would you want in test month rollover one? What is the date object you would create? And then what is the add days call that you would make? Something like the June. So you would say, you would call the date constructor with a particular year, month, and day. So we'll say 2024. I'll erase this because we're done with it. I'm assuming that the month and day are also stored as integers and not strings. So June would be month 6 and day would be month 30. So this is the actual date. And then we can say so we make an expected date and an actual date, and now we want to assert equals. Or we can say actual equals actual dot add days. And then we'll add a single day. And we'll reset actual to be that, and then we just say assert equals. Who remembers the order?
The expected first.
Yes. And there should be semicolons at the end of each of these lines. But this would basically, we want a timeout associated with this. So to complete the full test, we want to make sure that it's well formed, but this reads quite nicely. And then we would want some kind of string in here that tells you what message would fail. But we would see that test month rollover 1, we would see that the whole purpose of this is to roll over a day. So, all right. I'm gonna, from now on, kind of just describe these in English for what because a lot of the process, a lot of the difficulty of this process is coming up with what are the good tests, not so much implementing those tests or writing those tests. Although you do want to make sure it's a good test and not a bad test, but a lot of the difficulty of this comes from the design process. And that's a lot of what I want to focus on in the class. You can all look up on Google or ask ChatGPT, write me a JUnit test for this particular, it can find the syntax for you. So from your perspective, from my perspective, it's not as important for you to know the exact syntax for that. What ChatGPT can't do is say, here's a class, write a good test suite for it. That's going to be significantly harder for something like an artificial intelligence. So test month rollover 1 will be, I guess, how do I want to do this? All right, we'll call it that. What else should we test?
I would maybe think you want to do month rollover, but taking away a day.
Yeah. Yeah,
What about testing for the case of December 31st to January 1st? Because not only are you changing the month, you're also changing the year.
right. So we would probably also want to test that would hit both the year rollover and month rollover. So we could do that. Test year rollover. We'll test December 31st plus 1 day.
Want to test rolling over multiple months, so like plus 32 days?
Yeah. So, and, we can pretend like the academic year is over and then cry when we realize it's not. So something like that. Sure. What else?
Going back a year, so June
Yeah.
1st minus a day.
Yeah. Something like January 1st minus a day, so year rollover backwards.
And then maybe just do it like just a year, so plus 365 days.
Yeah, make sure you end up at the same date. And maybe you want to test that for leap years too. We haven't tested anything with regards to leap years. So it could be that your leap year logic is wrong. There are tons of tests you could write here. What I recommend thinking about is both, what is the severity of these tests? So how likely is this test to fail? Given all of the other tests so far that you've written have succeeded, what is the most important thing to test? So I would argue if we had written all of these tests, the most important thing that is next to test is some kind of leap year or leap day, because that is not embedded in this test whatsoever, in any of these tests. So that will change based on the existing tests. Once you have a pretty good test for a leap year, you'll need to think about, all right, what's the next most common way this could fail that these other tests would not catch? And that will allow you to write relatively few tests that capture relatively many bugs. Because we don't have an infinite amount of time to write an infinite number of tests, because is there any way that we know for sure that this data object works? Not without writing a bunch of tests, possibly infinite tests. So we just need to use our intuition and our problem solving to figure out what are the most likely ways it's going to fail, and iterate over that and write tests with the time that we have. Eventually, it's just not worth writing the extra tests, right? You've written 30 tests for this object. Is it worth the time to construct the 31st? It's probably time to move on to the next thing. So this is an important part of writing code, but it should not be all consuming. If we wanted to draw a graph of this, this is one way you can think about testing. kind of inverse relationship like this, where on the x-axis we have the number of tests written so far, and on this axis is the importance of writing the next test. If you have no tests, the first test you write is going to be the single most important thing to validate as much as possible. So the importance of that test is very high. The next test you write is also going to be relatively important. The first many tests are going to all be important, but eventually it starts tailing off. And for a very important application where your clients may die, you want to make sure you're still writing tests all the way out here. But if you're writing something like a date object, that's not going to kill anybody, it's not going to cause anything major to fail, maybe you can stop right here. But if you stop right here, you want this test suite to encompass as many bugs as possible. It'd be very easy to just write a bunch of relatively similar tests, but then you're not testing the important parts of the code. I think that's probably as good as we need to go into for the exercise. Anyone have any questions about generating tests, relative importance of tests, how to write the tests?
So would you want to start off with like your first test be something that could catch all of that? Like day rollover, month rollover, a year rollover, and a leap year?
I would start with something like, how much time do I have to dedicate to this? Because how much information is that single test going to tell you when it fails? Something went wrong, great, my program doesn't work. So you need some way of knowing what parts of it failed. So if you have a whole test suite and you see that your day rollover and your month rollover work, but your day, month, and year rollover failed, you can start to logically see and determine, I think the year rollover is what's not working here. And you can use multitudes of tests to be able to logic that. So yes, that's a very good test to write. But it's very infrequent that I would say that there's one good test that one test will capture everything. But yeah, that's part of the important problem solving process of just figuring out which test do I write. Other questions? That was an excellent question. All right, the next thing we want to talk about is some redundancy. We're going to end up talking about redundancy a lot in this class because it is something that is very important in industry, is making sure that you're not writing a bunch of duplicate code, or if you have duplicate code, being able to recognize that duplicate code exists and make your project smaller. The project's going to be big enough, just implementing all the necessary features. So if there's duplicate code in there that's further bloating your code, making it even larger than it needs to be, it's going to be harder to understand, harder to change when for some reason the project expands and you need to expand your code. You now need to go make changes in multiple places wherever there's duplication. And all of that can create a massive headache. So being able to factor out redundancy of things is super important. Same with redundancy in tests. So here we have a potential add helper function. So we're going to add days within the same month. We're going to wrap to the next month. And the add helper is going to factor out this process and allow us to add any particular number of days and then check and then write the assert statement so that we don't need to duplicate all of this code across all of the tests that do this same kind of thing. Have we seen this before or thought about redundancy in our code in prior classes labs and tried to factor that out into a method whenever you see it? The same is absolutely true whenever you write tests. It's very easy to duplicate all of the code in your tests, and that makes your test suite really long and hard, and also can introduce bugs if you just copy and paste without really thinking about what you're copying and pasting. You can easily introduce some kind of new bug into your program. So it's worth, whenever you can, factoring it out. Does anyone see any potential issue with this add helper function?
There's no test for the add helper.
Yeah, there's no test for the add helper. So we need some way of ensuring that this is going to be correct. I think it's probably okay. We're not doing any real logic in here. There are no conditional statements. There are no loops. there's no real logic except that we're making objects, calling functions that exist in the working code and making an assertion. So I don't think there's any way that this could go wrong, unless of course you have a syntax error, you pass the wrong parameters or in the wrong order to the constructor. That could cause your test to fail in ways that you weren't anticipating. It's not overloaded is the main issue with the add helper. So if you write a helper like this, it's very useful if, for instance, you know something about it in one case and don't in the other. You can write overloaded methods that always pass in the appropriate information. So for instance, this gives us the ability to pass in a year, a month, and a day separately from a date object. Maybe that's useful, maybe that's not. But it allows you to use the same syntax for that, depending on the information that you have. Any questions on overloading functions? We all know what I mean by overloading functions. I see some blank stares. Does that mean no, or does that mean yes? Give me a set of thumbs. Overloading methods. Understand it perfectly. Would love a refresher, but I think I remember some of it, and I have no clue what you're talking about. All right, let's give you a bit of a refresher about what we mean by that. All right, so we have two methods with the same name. Is that allowed, yes or no? Yes. Why? How do we know the difference between these two methods?
Because they have different inputs. One just has a date and an int, and the other one has multiple ints.
Right, so if you play the role of the compiler here, and the compiler's task is to determine basically which function, given this add helper in this code, what code should I run? If you play that role, how do you know which one to run? Number of arguments can be one, for sure, if they differ.
Type of arguments.
Yeah, the type of arguments. So for instance, here we have 1, 2, 3, 4, 5 arguments. If we look at the actual data types of those arguments, D is what type? We already know it's a date because it's up here. So we're looking for some constructor that takes a date object followed by what is positive 32. That's an int. What is 2050? An int. What is 4? An int. What is 2? An int. Is there a constructor for a function called add helper that takes date int, int? Right there. So it knows to call this, and it does not match to int. Even though it has the same name, it can map the number and type of parameters to the associated code that also has the same number and type of parameters. Now let's say I wrote another add helper function that took a date, int, and int. Is that legal? Having two functions with the same number and type of parameters? The answer is no, it is not. And the reason it is not is the compiler would not be able to differentiate between them. Think of it like you and a perfectly identical twin. Absolutely identical, nothing distinguishing. You're wearing the same clothing. How do you know who is who? You don't. Whereas two random students in this class look different, have different names. You can easily identify who is who by the fact that they are unique in the class. The compiler also needs to be able to determine uniqueness. Even if the name is the same, if they look different, then they're different. So that's the concept of method overloading. That's what you need to make sure of if you're going to method overload. Questions on that? That's why we have two helpers here with the same name, but they have different parameter types and parameter numbers. All right, another important kind of testing. This is called regression testing because we're going to change up our code. And then our code is no longer going to work when we add some feature to it. So this happens frequently when our code changes, when our code evolves over time. We talk to the client, and the client who wants us to make this particular software either says, oh, no, I didn't want you to do this. I wanted you to do this instead. Or, oh, I'll also pay you if you throw on this extra feature on this program. I didn't tell you this before, but I think that would actually be really exciting and useful and relevant to what I'm paying you for. So now you need to go edit your code and include that extra functionality. That may involve going back to classes that you'd already written and changing them. That may involve extending inheritance hierarchies. It may involve adding in new design patterns that we're going to start talking about in the next couple of days, couple of weeks, probably next week. So code is going to change. And features that used to work, whenever you make change to code, things can break. Has anyone experienced that? You have a lab working or at 98% working and you go make some change that you think is going to make it work 100% and it makes it work 4% or 0%. Everything breaks and it no longer compiles or gives you an exception that you weren't expecting. This is what regression testing can help you with. So when you go introduce a new feature or some kind of bug fix, you can make a new bug, introduce a new bug, reintroduce an old bug that used to be there that you thought you'd fixed. So regression testing is when you run your old tests after a change. Whenever you make some kind of change to your code, you're going to rerun your tests and make sure that what used to be true is still true. Since this is a huge pain to do yourself, you're going to usually automate this or write a script that is going to do this in some way, shape, or form for you. Because actually manually running your test suite after every change is just something that has to be added to your process, your development process. And as computer scientists, we like optimizing and minimizing the amount of work. Our jobs are already difficult enough as is. If we can make our lives simpler, we should do so. If a little bit of one-time work can make the rest of our lives significantly easier, we will do that. What's nice about this is if you've written a test suite like this, what you guarantee is that you have a minimum level of functionality. If you've tested that your object can never get into an invalid state, for instance, then you give your entire application, you always know that, all right, I cannot get into an invalid state. You're always testing that. It allows you to make claims about your code if you've thoroughly tested certain features. You can also do this remotely for those of you who have, well, we've all used GitHub at this point, at least made an account. But this is called continuous, oh my gosh, continuous integration, where whenever you commit code to a repository, it's going to run the suite of tests and make sure that all of your tests pass before you merge your tests. We'll dive into this significantly more in 350. I don't know if people talked about or thought about their schedules into the future long enough to know when you're taking 350. Anyone taking that this spring? Anyone taking it next fall? Don't know yet.
Is this the only requirement for it, or do you need the 8?
I think you need the 8 for it.
I gotta worry about that first.
Yeah. Assuming that you pass the 8. I'll be teaching software engineering next fall and spring, so I'll probably be seeing some of you in that class at some point. There's nothing that says that you need to take it immediately after this class, but it is kind of a natural continuation of a lot of what we're talking about. We'll talk about it theoretically, and the problems that you're going to get are kind of self-contained because it's still individual labs at this point. But in software engineering, you're going to be producing a significantly larger project in large groups of 5 to 6 people. So what that means is that you have to learn how to communicate, how to work together, what happens if you make changes to code that other people weren't expecting, how to use all of GitHub's features to be able to collaborate. All of that is very important for how you computer science out in the workforce. We like to all think that we're introverts, and then we get to a job and realize that we don't have any room or space to be an introvert because there's so much communication that needs to happen when you're developing software. So regression testing is very important, but it can be automated. I talked a little bit about this some number of days ago. Test-driven development just is a type of development that says, when is the appropriate time to write your test suite? And test-driven development test suites are written before any implementation. We talked about that you do in fact know all the information that you need to be able to write tests before you write the code. You can outline what methods, if we think back to Friday's class where we were doing our programming problem of the fundamental theorem of arithmetic and the largest prime factor of a number, we outlined the methods that we needed to call and the associated behavior of those methods before we wrote a single line of code. If we know what methods exist, then we can write tests for that class, just like we didn't need to know the functionality of the methods in the date class. Who knows whether or not that code is actually implemented or not? It did not affect our ability to write tests for it. What do we think? Benefits to writing tests before code? Drawbacks to writing tests before code? What do we think?
I feel like it'd be really easy to write to the tests.
To write the code to the tests after you make the tests? Sure, but maybe you're also thinking about some things after writing. It's like, oh, right, there's extra logic that I need for a leap year. And I know that because I thought about it when writing the test. So I see that as kind of both a pro and a con. What else?
You know that it works.
You know that it works. At least you know that when you finish implementing it, you have some tests backing it up that says that your intuition was correct. And you don't have to finish writing the code and then think about writing the test to be able to test what you just wrote. That could be useful. So I think one of the biggest benefits is that it allows you to plan. Novice computer scientists in general do not spend anywhere near enough time in the planning stages of writing code before just jumping into the implementation in general. So that's something that's very difficult to learn. If you get in the habit of test-driven development, I think that can really help people learn to plan, learn to think through things, and write code that has fewer bugs. How about some drawbacks?
You can write a bunch of tests and then end up not implementing that code.
That's
Anyway.
true, right? If you write a bunch of tests for what you think the development is going to look like, and then you actually go develop it and that changes, or the requirements change between when you wrote the tests and when you implemented the code, maybe you wrote some tests for nothing.
Or didn't write enough tests.
Or didn't write enough tests. Yeah, that's absolutely right. All right, let's talk about some very final bad habits that you can get yourself into when writing tests. So constrained test orders. If you have tests that rely on each other, so test A has to run before test B can run. It's not in a state to run without test A, you paired them up like that. That's generally bad design. So what can we do about that? Let's say that you are looking at code somebody else wrote. They have 2 tests. One of them requires the other to finish before it's able to start. What can we do about that?
We can use the necessary information that we have in A and just implement it in test B, so if test B runs on its own, it fills in that information.
We could, but then we get the other error of we have two assert statements in the same one, so if A fails, we don't know anything about B.
Could you just do test B assuming that test A pass?
Test B assuming test A passed, possibly. Yeah, that would be the idea, is you wanna write the tests and really think about this. So you can easily run test A and test B in such a way that. So you'd probably wanna do something like. Test A as a single test. And then. Test A plus B as a second test. That still does this logic, but doesn't have an assert statement associated with it, and the goal of this is to test A, and the goal of this is to test B that relies on it. And this way you can't possibly run a test that's gonna fail due to lack of information. If you write a test that calls another test. I see this a lot. It's generally hard if a test is going to fail. We don't know what caused that failure or which function the failure was in. Maybe it was part of the setup that happened before test A called test B. It just increases the number of places in our code where something could have gone wrong. And anytime you could write a test that calls another test, you can write two tests. So in general, we want to keep these as small as possible. We call them unit tests because they test one small unit of code in one small way. So unit tests should be short, straightforward, and to the point. If you wanted to do something like this, you could also factor it out into a shared helper method. Totally fine. That reduces redundancy, looks good, but you're still testing two separate things at that point. The assert statement and the logic is all embedded within one call. There are not two possible places it could go wrong. Concept of a mutable shared state. So if there's some object that you construct and then multiple tests use that same object, this is bad because test A may modify that object in a way that causes test B to fail. Test B may modify the object in a way that causes test A to fail. So now depending on the order you run the tests, it might be testing something different. So you should always make the object within the same tests that you're testing them. Don't make it in the begin class or the end class in a way that is going to affect each tests. So if you're modifying an object and then leaving it, that's bad. Always start with a fresh blank object. Think how difficult it would be to find that kind of associated bug. You ran test A, it changed the object such that test B would fail. And if test B were handed an empty object, it would succeed. So you try to reproduce the failure in test B, and you can't because you're assuming that it's starting with a blank object. How do you know? You actually have to look at the order the tests were written and kind of like a whole project, work through all of the logic in order to try to figure out why is this bug happening. And it's all in how you wrote the tests. Test suites, we've talked about this all along. One class running many tests. So here's the syntax in Java for you to be able to write a suite class. So you would have run with suite.class. So this just tells you what object you're pairing this with. And then you just do this, you write each of the test names, the test case name .class, and then you start writing your tests. So a couple important imports in order for you to get there. Runner and runners. And this just sets up your entire suite for you to be able to just almost vomit unit tests to make sure that your objects work. So let's recap. Last thing we're gonna talk about with regards to testing. Tests need failure atomicity, which means that you need to know exactly what failed. When you run a test and the test fails, you should be able to isolate within seconds what happened. If you can do that, you wrote good tests. If you can't do that, you wrote bad tests. So as part of this, you need a long descriptive name. If your tests have good names, then great. The name will tell you what went wrong. Assertions should have clear messages, so you always know exactly what went wrong from reading the message, and you don't have to refer back to the test code. If you write a bunch of small tests instead of one large test, each small test is testing one particular thing. If it fails, you know exactly what failed. Use a timeout parameter for every test. You never know when that's going to trigger. Test for expected errors and exceptions. You're not just testing for whether something works. You're going to test if it doesn't work, does it fail in the way that I expect it to? You want to choose a descriptive assert method. You don't just always want to choose assert true. The different assertions will have different amounts of data and kinds of data embedded in them. So you want to pick something that, again, reveals information when it fails. If you have equivalent input classes, you just want a bunch of different test cases that will actually look at those input classes. And then you want to avoid complex logic, so no if statements, no loops. Try to avoid all of that. Should be straightforward. Use helpers. You can use at before, at after, at before class, at after class, and that will all help reduce redundancy between your tests and keep your test files relatively small. Note that there's no guarantee that your test file is relatively small. Usually, your test file is larger than the actual code. At my last institution, we had auto grading software. And so one of the ways that the auto grading software works is you have an input file, and this would be, a lab that a student wrote. So we have some kind of input program. That's a program that you would write. And then we have a bunch of tests that work on that program to determine, does the program adhere to the lab standards, yes or no? And just like with your own tests, who knows if the program fully works unless you have a bunch of tests for that. So the size of some of those test files is massive. They can be thousands of lines to test a 210 lab, just to make sure you can do things in your tests, like look at the actual number of methods in a program. You can look at it and make sure that certain parameters are being passed in certain orders. You can do anything that you would want to break apart a program and make sure that it's constructed in the way that you were expecting. So JUnit tests are incredibly useful beyond just testing your own code. They can test other people's code. So we are out of time for today, but we're going to come back tomorrow and start talking about code smells. What do I mean by code smells? It's stuff you can do that makes your code smell bad. Make your code stinky, and we need to give it a shower. So we'll start talking about that tomorrow.
Thank you.
Thank you. Have a good day.